welcome to Arduino tutorial number 9, hosted by the real Tony Stark. In this tutorial, we'll be covering topics such as modulo, tone, and functions. Finally, functions. For this tutorial, you will require the Arduino software, the Arduino Uno, a breadboard, some resistors, an LED, speaker, a push button, some jumper wires, and a coconut. Very important. Multi-purpose. Okay, let's start with some of those weird, strange words that I said earlier. If we go to the Arduino website, as I mentioned, we will be dealing with, now, as you may notice, I've already got the breadboard set up here. This is because it's essentially the same setup as the previous tutorial that I did, where you have a push button and an LED. The only thing I've added here is a small speaker. Now this thin speaker you can get from SparkFun, and it's like $2 or something. Now you can get a bigger speaker if you want better quality, but actually the quality on this one's pretty good for considering how small it is. And all I'm doing is I'm going to hook up one of its wires to ground, and the other one is going through this brown over into any of the digital pins. I'm going to say 7. Now, it is advised to put a resistor in line with this. It does make your speaker quieter, though. So depending on, you're going to overdrive it, which means you're going to put more strain on it without a resistor, and it will die sooner. But it's a trade-off, so it's up to you. I rarely use one, and I haven't had too many issues, but it's not good practice. So, put a resistor in there if you like for this demo, just so to make sure you can hear everything. I have not included one. Okay, and then I've got my push button hooked up to a 0, and I've got my LED hooked up to pin 9 with a 330 ohm resistor. That's it for the setup for today. Now, as I said, we will be covering topics like modulo. And if you've studied any type of math beyond high school, you will definitely have heard this, or even actually in maybe high school probably. But regardless, we're going to show you what it does today. As you can see here, it falls under the arithmetic operators. So other ones that we've already used are equals, plus, minus, times, and divide. And there's that little percent sign, which does not mean percent, modulo. So we'll cover that. We're also going to do tone, which introduces us to our first library, advanced input-output. Yeah, it's not that advanced. It's pretty straightforward how to use this, as well as no tone. And then lastly, we'll be using functions for the first time. Well, you've actually kind of used one already if you've been doing my tutorials, but we're going to make our own today. So, let's get started. What is modulo? Well, let's go into the modulo link here, because it's really easiest if you just read their thing. Calculates the remainder when one integer is divided by another. Okay. So it's useful for keeping a variable within a particular range? Sure. What does it do, though? Well, here's some examples. So if we have x, our variable, equals 7 modulo 5, what does that mean? Well, it takes this first number, divides it by the second. Now, there's some weird math there you don't normally have to grab a calculator for. We don't really care what the result is. We know that 5 is going to go into 7 once, and then a bit more. So it's going to be 1 point something. However, all modulo cares about, when you use this is instead of dividing, we're using this. And what that means is 7 divided by 5. How many times does 5 go into 7? Once. What is left over? 2. Okay? So what we're really looking at here is the remainder, not so much the division. And this is, I use this, I'll explain where I use this in a moment. Here's another example, 9 divided by 5 essentially. 5 goes into 9 once, and there's 4 left over. 5 divided by 5, it's not 1, it goes in once, so the remainder is 0. And 4 divided by 5, well, that doesn't work at all, so the remainder is the original number. Okay. Now this one here, in my opinion, this is what I've used it for most, is to find out when the remainder is equal to 0. So what that does is, if you are doing any sort of math calculations in your code at all, if you want to find out a specific time whenever the nice equation comes out with a remainder of 0, whenever it divides out nicely, modulo is great for that. So they use it in different methods here. Okay, for counting, it's very useful, and that's essentially what I've been doing as well. So just to keep in mind, we're not going to use this today. I just wanted to go over it because it is one of the only arithmetic ones that are not maybe commonplace in regular math that you do. So this is, yeah, that's modulo. Okay, let's get on to our tone. Now, tone is used for creating an audio tone. That's why we have a speaker. So we're going to do that today. I use that in a lot of my projects, almost all of them, because I do like to have some sound effects going on with whatever it is I'm doing. So let's minimize this. Let's open up our code window. And I've already got the bare minimum open. Okay, so again, you can find that files, examples, basics, bare minimum. Okay, great. Now, if you also go into the file examples, you will see tone down there. Now, that is in my examples. It does not necessarily come standard with your version. Now, I've added in a separate tone library, and there's a reason for that, and I will talk about that at the end of this tutorial. But for the beginners, for just creating any sort of tone, we're going to do what we always do, and let's create some variables. Let's set up our code here to work, and let's just make it generate a tone first. Let's see how that tone code works. So first thing I want to do is I want to create my speaker pin. So const int speaker pin equals 7. Speaker pin. Great. Okay, I guess I might as well do my LED pin equals 9. LED pin. What else got here? Const int button pin equals A0. Push button pin. And let's go. Yeah, that's probably good for now. Let's go into our setup. As always, I now always begin with my serial.begin 9600. And again, this is for troubleshooting. This is to see what our code is doing on the screen. To use a serial monitor. So generally always good. Just start your serial at the beginning. Okay. Well, what else do we want to do? We want to say pin mode. Let's designate our pins. Pin mode. Speaker pin. Output. Okay. Pin mode. LED pin. Output. And pin mode. Button pin. Input. Great. Well, what else do we got to do? Let's go down here. First, let's get our button. No, we'll do the button after. Let's do our speaker first. Let's just generate a tone. So the code for this, if you write tone, you'll see it goes orange. Okay. So tone, open bracket. Now, there are 2 or 3 variables that you can put inside these brackets. The first one is, what pin are you generating the tone on? So in this case, it's speaker pin. Okay, that's the first one. Now the second one is, what pitch of tone are you generating? And that is done by talking about the hertz of the tone. So hertz is the frequency of the wave pattern. And all that means is a lower one, it goes from 0 up to the upper range of human hearing. I mean, you can go up to like 22,000. So I mean, there's some point you're not going to be able to hear it any further. It can generate those tones. But for our purposes, anything between, like, I usually don't go higher than 8,000 myself. Haven't really found a purpose for that yet. But yeah, so let's just generate something. Let's try something around the 1,000 range. Now, you could stop it there. The last one is duration. So how long do you want this tone to go? And this will affect when you want to do a changing tone. So in my repulsors, I often do a increasing sound. And if you have it only going for like 1 millisecond, you'll hear a lot of breaks between the tone, and we can test that in a little. So I usually go for something around 10 milliseconds, even 100 smooths it out. But it usually corresponds to whatever I do right after, which is delay, for the same amount of time, usually. So what this is going to do, though, don't forget, this is going to loop this, right? So we should just hear a consistent tone regardless of the fact that we put a 10 millisecond delay in there. So maybe what we'll do is let's upload this, and that's going to be extremely annoying once it starts running, but that's okay. Let's give it a shot here. Upload. Nice. That is beautiful. Okay, so I'm just going to unplug that. Now there was a bit of fluctuation there. Let's see what happens if we put in 100 and 100. And let's upload. Let's see what happens if we change those numbers. It's still uploading here. Okay. So notice there's still that break in there, right? Now, what if I put in 1,000 for each? Oop. And upload. By the way, I apologize in advance. This tutorial is going to be highly annoying. Ooh. So now you can hear the break is spaced out. So you can hear the spot where the loop is restarting. It's running this for... Yeah. Now, let's see what happens. What if we do 1,000 for the duration of the tone and only 100 for the duration of the delay? Let's see what happens. That blip is gone. So what you found is when we had that, I'm going to unplug that, the little break is gone, and that's because the duration of this is extending trying to go for the full 1 second, but because the delay is only lasting 100 milliseconds, that is carrying over to the next time it goes through, and so therefore you eliminate that vibration or fluctuation that we probably don't want. As you saw, I got a pretty consistent tone there. Okay, so that's it. So we can try something higher here. Let's go something like 4,000. Upload it. That 1,000 sounded like somebody died. Okay, so that's much higher and much more annoying. So as you see, it climbs pretty quickly. If you go something even at like 0, let's see how that sounds. Okay, 0 doesn't work, so how about 1? So you get almost like a Morse code type sound. So it does play certain pitches better than others. It can only go so low. So just keep that in mind when you're generating your tones, what you want to generate. And there is online, if you Google like Arduino tone frequency, if you actually want to play songs with this, you can definitely do that. There are tutorials online for or lists online of what frequency matches up with what tone. Okay, so that means our tone works. Great. What do we want to do with it, though? Well, I have a button on here and I have an LED. So we're going to generally or essentially create our repulsor circuit or code right here. Well, let's do this one thing at a time. What do I need to do first? Well, let's test the button pushing, see if we can get that. Now, if you watched a previous one, you can try this again. Otherwise, I'm going to go through it pretty quick here. Let's create an integer, int button state. Actually, I guess we'll just make this a Boolean, because it can either be true or false, equals digital read button pin, and that's it. Read push button. Okay, so all this should be doing right now, it's going to be checking is it true or false. And we're going to say serial.print button serial.print line button state. Great. Now let's upload. So this is going to print the word button, and then it's going to print whatever the value of this is. And let's go serial monitor. Button saying it's 1. If I press it in, 0. 1, 0, 1, 0. Great. Okay, so button pushing works. That part's done. What's next? Well, when I push the button, I want the LED to shoot. I want the blast to happen. Okay, so let's go and do that. So we'll say when it was not pressed, button state was 1. So if button state equals 0. Okay. Well, we want to fade that up. So let's use a for statement. For int I equals 0. I is less than 255, and I increases by 1. And what do we want to do each time? Well, we want analog write, because we're on a PWM pin number 9. Analog write. Let's go LED pin I. We're going to write the value of I to the LED pin. Now the other thing we want to do here is delay that so we can actually see the effect. I'll say 30 milliseconds. Okay. So what this is going to do, let's just check it. If its button state is 0, then from 0 to 255, we want to fade this to on. Then what's going to happen? Well, it's going to finish fading it to on, then we should turn it back off. Okay? So let's say analog write, LED pin, 0, done. Turn LED off. Okay, and this one I guess would be and if, and this is and for. Okay, great. Let's upload it and see what happens. Okay, it's running. We can bring up serial monitor if we want. Button is 1. If I push the button, it fades on and stays on. Oh, it's off. Okay, good. Let's try it again. So button, it's still reading as 0 because it's not checking while it's fading, right? It's going to keep fading that all the way on. Now that's a little longer than I want to wait every time, so I'm going to reduce that to 10 milliseconds for the delay, just so we can speed up the process when we're monitoring this. But depending on, you got to play with it a bit to see how long you want your effect to last. Here we go. Much better. Now as it approaches at 255, it's harder to distinguish the increase in brightness, but that's a little bit more reasonable for us to work with. Okay, and that does work. That's great. However, it's not enough yet. It's not good enough, because what happens if I hold the button in? Does that do anything? Let's see. Okay, so it keeps going. Now, depending on what you're using this for, that might be okay. If this was my repulsor, now I don't use a push button for this, I use an accelerometer or a tilt sensor. And this would essentially mean if I'm holding my hand in the blast position, that it would just keep firing, whereas the effect I wanted was to hold it up, fire, and it wouldn't fire again until I reset my wrist. So, this method is close, but not quite there. So that's one thing we may want to look at. Another thing is, we need sound effects. We just learned how to do tone. Well, let's do that. So what I'm going to do is look in the code here. I've already got that delay. We're going to pair that up here. We're going to animate the light and do the speaker at the same time. Now, one thing I should mention, on most Arduinos, other than the Mega, and maybe some of the later versions that have come out recently, using the tone library and sometimes using other libraries will affect some of the pins, especially the PWM on the Arduino. And there's something called a timer that's connected to those PWM pins. There's timers 0, 1, and 2. And in this case, pins 3 and 11 can be affected or will be affected by the use of the tone library. So keep that in mind. Also, if you're trying to play two tones on multiple pins, can't be done with this included tone library. So just keep in mind, if you want to play two different speakers, you're going to have to alternate them, and you will have to stop the tone on one in order for that to work. And we'll cover that again in a moment. So here we go. Tone, speaker pin. What do we want to do? Now, this is where, what do we want to happen? If I say 1,000, let's just try this. Let's say that 1,000 one, and we'll say, let's run it for 100, just so that it overlaps longer than our delay. It won't actually get to play that long, but we will hear the blended tone better. Okay, so let's see what happens if I do this. And push. Oh, my speaker one came out. Okay, so that's kind of good, but it plays the same tone, and that doesn't sound like a repulsor to me. So when we look at our code, what we're actually wanting to do here is not do a constant value. We want to do something that changes with I. Alright, whatever this 4 is increasing, but this is only going from 0 to 255, and as we heard, something in the lower range of around 1, 0 didn't give us anything, 1 gave us almost a blip, and 1,000 is already kind of low. So what I do in this spot, you can actually do some math right in here. So what I would do is I would say I times something. So what is the range of values that you want to do? Now you could map it, but I'm just going to multiply and get an approximate value because I don't need anything too specific here. I would like this to go from about, maybe from, 500 up to 4,000, something like that. So let's assume this is 250 for easy math, and we'll start from 1. So if I becomes 1, the first time through, or second time through, I should say, through the for statement, if I is 1, what do we want to multiply it by? Okay, and what if we multiply that by the last one, what do we get? Well, 250 times 4 is 1,000. So the highest I really want to go with this is like 8,000. So to get from 1,000 to 8, we multiply by 8. From 1,000 to 8,000, multiply by 8, and we've already multiplied that by 4. So that gives us times 32. So I'm going to do times 32. So that will get me all the way up to 8,000 for the final point, and it will start me at from 32. That's fine. I can work with that. We could play around with this some other ways, but I think that's enough for us to demonstrate what we want here. So let's go and upload that and see how that differs. And again, this takes a while to find out your pitch range, what you want to accomplish. Oh, that was pretty good, actually. Okay, so what you're getting there is now the fading light effect and the sound effect. Again, I think it's a little bit longer than what you want, but it does accomplish the sound effect that we kind of wanted here. So, moving on, what else do we want this to do? I don't think it's done yet, because again, I can hold it. We want that to maybe reset. We also don't have a blasting sound effect there, and maybe you want to add that in. So, the tone, again, how do you create those pitches with a single tone? It did take some playing for me to finally get it. I did use nested for statements, I will tell you that. But the bigger thing that I wanted to address here was the function. This is something we want to happen every time I push that button. And it's working okay here because all we're having happen is this piece of code. If I had a whole bunch more going on here, if I was monitoring other things simultaneously, this would not work very nicely here. And this is where we get into functions. Okay, so let's go create our own functions. Now functions, as I mentioned, you've already used. This void setup and void loop, you've already used those. Those are included functions that need to be in every one. If you want to make your own functions, we go down past the void loop. Oh my goodness. Okay. And we're going to write it almost identically to what you have here. Now, there are different ways to introduce, a function. This one here says void, and we're going to use that for ours as well. Void is simply a block of code that you want to run. It does not return any values. However, you can use other things like int. Okay, you could have a function that gives back an integer at the end of it. So let's just start with this void. What do we want our function to be? We want it to be void blast. Okay, or let's call repulsor blast in this case. You can call it whatever you want. So we type in the name, we go open bracket, close bracket. Now, for void, it doesn't really matter because we're not doing anything with this. But if you had, say, you could use this here a bit too, but usually if you're going to have this return a value, this is where you'd want to carry a value into here. And so whatever you write inside, you would define a variable. This is all on the Arduino website if you want to get into more advanced function writing. For our purposes, doesn't matter. All we want this to do is be a separate block of code which helps us organize and run the same thing regardless of what else is going on. We want this to do that same blast sound effect and lighting effect. So instead of putting it here in the middle of the code, I'm going to take this piece right here, which is the thing that we are repeating. I'm going to cut it. I'm going to paste it down here in my function. And indent that, line it up, and at the end we put a close bracket. Again, our function is now summarized by here. So this is the blast function. Okay, and this has its own squiggly braces. Now it's called repulsor blast. So instead of if button state equals 0 and telling it to do this, I'm going to say repulsor blast bracket bracket, and it's important you have those brackets in there. This is what denotes it as a function. Okay, so now what it's going to do is you can call this from any point in your void loop. You can call repulsor blast, and it will go down here and run this code, come back up to where it left off, and continue on. So this makes our void loop a lot less filled with this kind of stuff. All right, and you can break up your functions and it's really good to do stuff that you want to repeat often. So what you'll notice if I upload this, we should get the exact same effect that we just had. So that's it. So it just breaks up the code more. So what else do we want this to do after this happens? Well, okay, just for fun here, I'm going to say, actually, I'm going to make this go. Yeah, that's fine. Yeah, let's go and make this do some sort of firing effect. Now, as I said, I used a... I'm not going to turn this off yet. I'm going to have the same thing happen here. Yeah. We're going to hold this on at maximum brightness. Delay. Let's say 500 milliseconds. All I'm doing there is when I get up to the top, because what's currently happening is it's getting up to the top and just stopping. I want it to pause there for a second before it, or for half a second, before it starts to blast. Now, the blast sound effect and lighting effect, I will do a for statement, and we will call this int I equals 0. Then we'll say I. We want this to eventually fade from on to off. Now, what's really cool is this just took some playing, and I'm just going to literally make this up right on the spot here. I have no idea how close this is to what I originally did. I could check, but I just want to play here and show you this is really how I'll do a lot of my stuff. Let's just see what effect we get with this. So let's do I is less than, I don't know, 10. Sure. I plus plus. Sure. Now, we're going to do another for. Int j equals, I don't know, let's go from 100. J is greater than 0. Sure. 0. J minus minus. Why not? Then, in here, now this is where we say, let's just try and figure out what this is going to give us. Well, first time I goes through, it's going to be 0. First time j goes through, it's going to be 100. Okay, what do we want to do with that? Well, let's go, I'm going to copy this stuff right here, because all this same stuff is going to happen here. Okay, well, let's see what we got. We have LED pin equals I. Now, I is only going to range from 0 to 10, so clearly that is not high enough. What we want here is we want some sort of a flickering effect. In my opinion, that's what I want. So I'm going to multiply whatever that is times 25. Now that's going to get me a range from 0 to 250. Close enough. It's going to be a whole bunch of iterations in there, and that's exactly what I want. Now, for the tone, this is where it gets interesting. Now I'm going to say something like I times j instead of a number. So what that's going to do is we're actually using both of the for statements to generate a combined number. So the first time we go through, it's going to be I is 0, j is 100. That's going to be a speaker pin of 0. Okay. Next time we go through this j is going to be 99, and I is still going to be 0. So that whole first time, nothing's going to happen. So you know what? I'm going to start this from 1 because that's going to be a wasted run through. Oh, now if we do this, j is going to be 100, I is going to be 1. Well, that's going to make this a pitch of 100, I times j. Then j is going to be 99. It's going to be 99 times 1. Great. We're going to go and get some, well, this is going to be interesting. Let's just see how this sounds. And that looks fine. We do, oops. And this for, and that for, and then I guess we'll turn off the LED. And this is the end of our function. So let's upload and see what happens. No idea how this is going to sound. I have some guess, but I don't know. We're just going to try it here. Ha! That was neat. Okay, so I don't think we need to go all the way up to 10. I think we can do something like 3. First of all, there's way too many repetitions. Plus, because we have from 100 down to 0, and it's doing 10 milliseconds delay each time, it's taking a whole lot longer than we want. I'm going to change this to 1 millisecond. Let's see how this sounds now, going from 1 to 3, and 100 to there, but only 1 delay. So 1 millisecond delay. Let's see how that sounds. That was much quicker. Okay. Let's try something like 5 delay, 5 milliseconds. See how that sounds. And because I only went to 3, I think we actually only got a twice there, but let's try it. Yeah, only twice. So I'm going to go up to 4. Now the other thing is we're increasing. If you hadn't noticed there, the tone is actually increasing, and that's simply because we're going from 1 to 4. So I think I'm going to reverse this. Let's start it from 4, and let's go greater than 1 and minus minus. So we're doing a nested decreasing for statement. Let's see how that sounds now. Okay, so that's closer, but I think we still need to do something different. I think it's going a little bit too slow. So let's try and make this like 2. And maybe we'll repeat this a few more times because I feel like it's going to go pretty quick. So let's upload it now and see what we get. Again, yeah, I'm just going with this for the repulsor sound effect, but we'll see. Okay, better, still pretty slow. Let's try 1 again now that we've got more times and we're going the right direction. Let's see how that sounds. Alright, so not bad. I think it might still have to do with the fact that we're going from 100 down to 0. It's taking quite a while to get through. So you can play with this and see what kind of sound you can get. We can do more iterations of this one and do less of this one. We get the same amount of blast time, but you'll get something completely different when you don't go from that same, because we're doing I times J, you get some interesting. Ooh, that one sounded pretty good. Now it's a little bit lower than I'd want, so I'd probably up some of these numbers, maybe even multiply this times 10. And now we get the same effect there, but higher. Again, all dependent on what you want to create. Let's do this last one here. Okay. Ooh, not bad. Okay, so this is essentially how I did my repulsor. That's really all there is to it. The only other thing that you may want to do, as I said, if I was to continue holding this down, you may want to add a separate variable in here to make sure that it's been reset. So really quickly to do that, let's go up here and make a new variable, Boolean, button reset equals true. Okay, so that means the button has been reset at this moment. Now, as soon as it's been pressed 0, this is where we're monitoring, right? Button, or has button been pressed? Okay. If the button's been pressed, now we want to tell it that button reset equals false, because the button has not yet been reset. This is where, instead of end if, actually I guess we'll just insert this here, we'll say else, okay, if button is not pressed. Okay, now regardless of whether you have been pressing it or not, all we want this to do is say button reset equals true. Okay, so what that's going to do is, here, if button is pressed, button reset is going to equal false. And it's going to stay false until the button is let go and it reaches 1 again. However, this if statement now needs to include the condition of and button reset equals true. Okay, which it does at the beginning. We've told it to be true here. So the first time through, if you're pushing the button and button reset is true, it will make button reset false, fire the thing, and then the next time it runs through, if you're still holding that button, button reset is still false. It has not been put back to true. So therefore, this will not validate and it will not fire again until you let go of the button. However, this else is now giving every other combination of these two conditions. So we're going to specify in here specifically button state equals 1. And actually, you know what? I'm going to break those up separately here. Because I don't know if it's going to be considering this button reset as well. And just to make it simpler, if these are two separate if statements, now I can monitor them separately. So this is all this is looking for. If button state is equal to 1, button reset is true. That's all we needed. Okay, and this is an end if as well. Great. So now if we upload, we should see that if I hold the button down, it will not continue to fire until I've let go. Perfect. No more firing. I let go, and it fires again. So that is it's called a debounce. Okay, there's other ways to do that. Basically, we're just making sure that the whatever condition you wanted is not continuously held, and there's a lot of places in coding where that's handy. So something like this, where you can check that the condition has been reset, and then make sure you unset it, and it has to be reset elsewhere. Again, don't forget your functions, very useful for blocks of code you want to repeat and call from anywhere in your void loop. Okay. Don't forget the modulo, which we didn't use here, but it's useful for checking remainders after division. And lastly, I did say that I would mention this tone library. So if I go into my examples, and I go into here, tone, and let's say, I don't know, the DTMF test. Okay, now if I open that up, what you'll see here is it has a hashtag include tone.h. And you can download this this tone library from the internet. You can install it in your Arduino libraries folder. But what you can see here, tone frequency 1 and frequency 2, you can actually play two simultaneous frequencies on the same speaker or on two separate speakers. And it's pretty basic here. What they've done is just an example dialing a phone number there's two different ways to do this. You can create some really neat effects. However, this does use up the timers that are on your Arduino, which limits if you can do PWM on some of the pins. So it's not always the best solution. Unfortunately, for the effects that I wanted to create with mine, I was not able to use this to generate the sound effects that I want. But you can do some really neat tones when you can play two simultaneously. So just keep in mind. And again, anytime you use an external library, this has to become at the beginning, this very, very beginning. Include and whatever library. So it can reference some of these commands that this is a capital tone, okay, not the lowercase one we just used. And it can recognize different commands that aren't standard in the Arduino software. Alright, so that's it for today. Next tutorial, I have no idea what we'll be doing, but I'm sure there's more for me to pass along. If you have any questions or comments, please post them in the comments section. And that's it for today. Thanks again for watching. As always, stay tuned.